Hello, my name's Richard Porter and I work as the Principal Engineer for Advanced Solutions at Yokogawa, Australia. I'm going to take you into the exciting world of Modular Procedural Automation and Exapilot. Modular Procedural Automation, or MPA, can be effectively used to automate and standardise operating procedures of a process plant. Exapilot is Yokogawa's application for MPA. With Exapilot, it's possible to capture operator knowledge and best practices. Having Exapilot in the control room is like having your best operator in the control room all the time. Exapilot has been successfully used in process plants all around the world. Exapilot has an easy-to-use drag and drop editing function for creating procedures. There's no need for coding nor DCS engineering. It is designed for operations teams to create and maintain their own procedures. Exapilot procedures are typically implemented in a hierarchical manner. There's a main procedure that includes multiple sub-procedures, then these sub-procedures can hold further sub-procedures, and so on. For example, a main procedure could be cold start. This main procedure would then include a number of sub-procedures such as start cooling water, start feed pump, start draft system, and so on. So, without further ado, let's look at an Exapilot demo. Firstly, we'll start with some background information to set the scene. This demo has been prepared using a high-fidelity replica simulator of a coal-fired power plant. The simulator faithfully replicates the HMI and dynamic responses of the plant. The simulator includes a feature for simulating equipment failures. I'll use this feature to trigger a fault and show how Exapilot can be used to implement a best practice approach to operating, especially in abnormal situations. In this plant, the coal in the boiler is ignited by oil burners. There are 3 elevations of oil burners in the boiler. These are the bottom, centre and top elevations. Each elevation has 8 burners, numbered from 1 to 8. In order to proceed with the startup, all 8 burners in a single elevation must be successfully lit. Unfortunately, burner failures are common during startup. When a failure occurs, operators need to make decisions about when to continue to attempt lighting an elevation and when to abandon that elevation and try a second elevation. When lit, each oil burner consumes approximately 20 litres of oil per minute. Minimising oil consumption by following best practices during a startup can significantly reduce plant operating costs by reducing oil consumption. The demonstration will show the process of lighting an oil burner elevation and how Exapilot gives operators guidance for when to persist with relighting attempts and when to move on. This graphic displays all the bottom burners of the furnace. An Exapilot procedure will try to light off all 8 bottom burners from B1 through to B8. The burners are further divided into 2 groups of 4 each. Group WC, consisting of burners B1, 4, 6 and 7, and Group EC, comprising of burners B2, 3, 5 and 8. The burners are, however, not lit off in groups of 4. They are lit off in pairs and in the following order: B1, B4, B2, B3, B6, B7, and then B5, B8 being the last pair. It is, however, not going to be a smooth run, since there is a malfunction on burners B2 and B7, whereby B2 will fail to light off at the first go, but will be successful in the next light-off attempt. Burner B7, however, will not light off regardless of subsequent attempts. As a result, all the bottom burners will be successfully lit off except burner B7. That means that the bottom elevation has not successfully started. Historical records have shown that further attempts at starting a failed burner will be unsuccessful. Therefore, it is best practice to move on to the next burner elevation, the centre burners C1 through to C8. This is a sample Exapilot main procedure. As mentioned before, Exapilot has a modular structure wherein procedures can be created easily by linking standard blocks or modules. In this demo, A sub-procedure will be referred to as a procedure for the sake of brevity. This demonstration will focus on the oil gun procedure in further detail. Once the main procedure is launched, there is a request for operator confirmation to start. Upon clicking OK, the procedure starts and, based on the current process conditions, moves to the right, then down, and triggers the oil gun procedure. Clicking on oil guns displays details of the oil guns procedure. The first step of the procedure is to check whether the permissives are met. Once this is verified, the procedure continues down and triggers the procedure called bottom burners, where all 8 bottom burners are placed in service in pairs in the sequence described previously. Clicking on bottom burners displays the details of the bottom burners procedure. The first block of the procedure is another procedure for starting the B1-B4 burner pair. This procedure has already been triggered as seen on the screen. Clicking on Locate Unit Procedure displays the B1-B4 procedure in the panel at the bottom of the window. Clicking OK will cause the B1-B4 procedure to run, which progresses to the right as shown on the screen. The procedure first checks for the burner startup permissives and then continues to the right, starting DCS operation of burners B1 and B4. This is displayed on the DCS graphic by the blinking shapes. Next, in order to ensure the light off OK feedbacks are returned from B1 and B4, the sequence waits for 30 seconds. B1 and B4 are lit off successfully as displayed on the DCS graphic by the white background colour. Subsequently, the sequence checks for the B1-B4 pair in service, and after verifying this, proceeds to the right to the end block, thus ending this procedure. In the top pane of the window, the upper level bottom burners procedure is now ready to start pair B2-B3. In the right-hand pane, Exapilot displays operator guide messages. B2-B3 starts the same way as B1-B4. However, in this case, burner B3 has started, but B2 has not started due to the simulated malfunction mentioned previously. Exapilot will wait for 30 seconds to receive feedbacks from B2 and B3. After that, B3 will continue to run as expected, but since B2 has failed to start, the Exapilot procedure will now move to the right and run the shutdown sequence for B2. The burner safety system requires the burner to be successfully shut down before attempting to relight the burner. This will now cause process alarms that can be accessed by clicking on the alarms icon. In this case, there are 2 alarms. B2 has failed to start and B2 has been shut down. Next in the sequence is burner pair B6-B7, which will be lit off similar to the previous pair of burners. B6 will light off, however B7 will not due to the second simulated malfunction mentioned at the start of the video. The inability of B7 to light off will cause 2 alarms just like B2. After B6-B7, the last pair, B5-B8, will be brought into service by Exapilot. Both B5 and B8 will light off successfully. As burners B2 and B7 have failed to start, the oil burners for mills WC and EC are not fully in service. Exapilot checks for this by verifying whether less than 8 bottom burners are in service. Since there is less than 8 in this instance, Exapilot will attempt to restart burners B2 and B7. This time around, the malfunction on B2 has cleared and therefore B2 will light off successfully. The procedure will then move down and across and then loop back to retry pair B6-B7 since B7 did not light off. The procedure will try to restart burner B7, however, as the malfunction has not yet been cleared, B7 will not start successfully. The failed restart of burner B7 will again cause 2 alarms. The procedure now moves right and down and asks for operator confirmation to start burners on the centre elevation, abandoning attempts to light the bottom elevation. Confirming yes has now finished all the steps in the bottom burners procedure and will therefore end the procedure. One level above, in the oil guns procedure, The bottom burners procedure is ended, and the sequence moves down to trigger another procedure for starting the corresponding centre burners. Lighting off centre burners will not be explained in stepwise detail, since it is very similar in concept to starting the bottom burners. In addition to starting the centre burners, the procedure will also shut down the bottom burners to conserve oil, as only a single elevation is required at this time. Shutdown of the unsuccessful elevation by Exapilot contributes to significant savings during a startup, as it is common for operators to leave the additional burners in service even though they are not required. The centre burners are also lit off in pairs in the same combinations as those of the bottom burners. After C2, C3, the next pair to light off is C5, C8. Once combustion is established on the centre elevation, the burners on the bottom elevation are shut down. This order of operation eliminates the need for a boiler purge. On the centre elevation, the remaining burners are successfully brought into service. As a result, a total of 8 burners have been successfully lit off using Exapilot. The oil guns procedure now ends. As all the steps have been executed, Exapilot seeks operator confirmation to end the main procedure. Upon clicking OK, Exapilot closes. It is well known that a good operator makes a difference to the operation of a plant. This demonstration has shown how modular procedural automation can be used to capture the knowledge and best practices of good operators and make these the standard procedures used to operate your plant. Thanks for watching this video. Be sure to see more videos from Yokogawa about our solutions for industry.